everybody. We have this problem now as one of our practice problems. So let's try to solve it. So the first thing we need to determine, is it a combined gas law problem or an ideal gas law problem? Now, we know, well, after reading this question, small children are occasionally injured when they try to inhale helium from a compressed helium tank. If a small child tries to transfer the contents of a 5.0 liter tank of helium at a pressure of 125 atm and a temperature of 20 degrees Celsius, how much moles of gas will they inhale? So we have a temperature of 20 degrees Celsius, we have the pressure of 125, we have 5.0 liters, which is the volume, and it's asking for moles. So this looks like it's going to be a, please excuse me, a PV equals nRT. A PV equals nRT problem. So now that we have our values here, we first see what we are looking for. And we are looking for moles. So for n, we'll put a question mark to indicate that we're looking for moles. And then we plug in everything else. So pressure is 125 atm. Volume is 5.0 liters. R, the universal constant, 0.08206 liters times atm. Okay. Now, these units, you will see, it seems confusing now, but it's going to help us cancel out all the other units for our answer to make sense. So temperature, it gave us 20 degrees Celsius. But remember, we can only use Kelvin. So to convert this into Kelvin, we must add this to 273. So 20 plus 273 gives us 393. Sorry, 2 gives us 293 Kelvin. So now that we have all of our values, we plug them into the formula and we just solve for n. So we said pressure was 125 atm. Volume was 5.0 liters. So that's pressure and volume. And that is equal to n, and n is what we are looking for, times the universal constant R, which is 0.0806 liters times mole, over K, liters times atm, sorry, over K times mole, and finally we multiply that by 273 Kelvin. Now, since we're solving for n, we need to isolate n. And in order to isolate n, you can see that we must divide this whole side by this term right here, so that n will be by itself. So let's do that. N equals 125 atm times 5.0 liters. That should make it much easier. And that's over this whole thing right here, 0.08206 liters times atm over K times mole times 273 Kelvin. Now that we've isolated N, let's cancel out the units. So we see that in the denominator here, we have K times mole. So what we can do, we can multiply this whole thing by K times mole, so it'll cancel out there. And there'll be a K times mole right there. So now, as you can see, ATM will cancel, liters will cancel, and K will cancel. So our answer will be in moles. So since we're looking for moles, we know we're doing it right. And our units match up so far. So all we do now is we plug in these values, so 125 times 5 over 0.08206 times 273. Now, what's most important, well, what isn't the most important, but it's pretty important, is sig figs. So whenever we multiply and divide, remember that we should always keep the lowest amount of sig figs. So the lowest number with the number with the lowest amount of sig figs in this case will be 5.0, because that has 2, 125 has 3, this has a lot, don't even worry about that, and this has 3. So we know that our final answer must have 2 sig figs. So now that we know the final unit and the amount of sig figs, we plug 125 times 5.0 over 0.08206 times 273, and we should get our answer. Okay, so after plugging this into the calculator, our final answer is 28 moles. Now this answer is good because it satisfies the significant figures, which is 2, and it has the correct units, which is moles.